Your stuff up. All right. Today we've got properties of similar triangles. What proportional relationships are formed? Read my text. What proportional relationships are formed when parallel lines or segments intersect other lines or segments? We're trying to do this today. Use properties of similar triangles to find define segment lengths and apply and triangle angle bisector theorems. Okay? Really and truthfully, you're going to cross multiply about as many times as you can stand, but I'm going to give you different problems in which to do it. Okay? That's what is in essence today's class. All right, here's what you need to write down. First thing we need to write down is our triangle proportionality theorem. And then I want you to do this. I want you to draw the diagram. And I want you to write the conclusion. Don't worry about the definition. Okay? Write it down. Let's see if it makes sense. I'll get out of the way. Okay, my triangle proportionality theorem says if a line parallel to a side of a triangle intersects the other two sides and then divides those sides proportionally. When you draw your diagram, I want you to think through this definition. If a line, EF is a line, and it's parallel to a side of a triangle. EF is parallel to BC in this case. Okay? And EF has to intersect the other two sides of the triangle. So it intersects AB and it intersects AC. So if it's parallel, it intersects them and it divides those sides proportionally.
Who is it? Dates? Journey dates? Okay, I'll have to print off some stuff for her.
All right. Okay. So check it out. It's really not that hard of a concept here. If I've got intersecting parallel lines right here through this triangle, so E to F is parallel to B to C, and it intersects with the other two sides. It divides it up such that AE over E to B is proportional to AF over FC. I know it says equals. Guess what you're going to be doing today, sports fans? Okay? You're going to be finding those side lengths by cross multiplying. Don't worry about writing this down, please. Don't worry about writing it down. Okay? Just listen through this. The time you get on your phone. All right? This is the opposite of what we just did, right? It's the opposite. What's your conclusion here? AE over EB equals AF over FC. Now, I took that same conclusion and moved it to my hypothesis. Okay? And what this says is, what the converse of this says is, if a line divides two sides of a triangle proportionally, then it's parallel to their side. In other words, if I take the measurement of A to E over E to B, and that measurement is proportional, has the same ratio of A to F over F to C, I can conclude that EF is parallel to BC. Okay? So in the first example, I took this information to conclude that this was true. And in this example, I'm taking this information to conclude that that's true. See how they chase each other, right? So sometimes you'll be given that these are parallel lines and you'll be solving for a side. Sometimes you'll be given 4 of the sides and asked if they are parallel, right? Check it out. Assume that ST, we're going to do like this, is parallel to UV. That means that US or SU over UR or RU, either way, is proportional to T to V over V to R, or the other way. It's fine. Okay? I would have to find US. Here's how I would do that. Set up my proportion and cross multiply. US, so let's just call it X. X over 14 would have to be equal to the same ratio as 4 over 10. Cross multiply, I get 10x equals 56, because 4 times 14 is 56. Divide both sides by 10. They put this in fraction form, 5 and 3/5. It would be the same thing as 5.6. I'd rather you do it easier on everybody. Let's try and do this one. Write down this example, try and work it out on your own. There's 3 that work. Okay. Ms. Faulkner. Pardon me? Pardon me? Ms. Faulkner. Ms. Faulkner, can you name for me the parallel lines or line segments in this case? Please. LM is parallel to PQ. LM is parallel to PQ, which it is, and PQ intersects or touches the other 2 sides of the triangle, then those other sides of the triangle are proportional. That's cool, right? Yeah? So how'd you set this up, Ms. Faulkner? Whatchamacallit is a candy bar. Very underrated. It's actually pretty good. You guys don't ever. Whatchamacallit's a candy bar. Looks like chocolate, peanuts in there. I like it. I never had one until I started dating my wife, and I was like, so much about it. Just like this. I was like, so then she went talking with it. It's pretty good. All right, Heather, what am I trying to find here? PN. Okay. So the Trying to find that. Great. Yes. You're taking me off. Tell me, how did you set up this proportion? Okay, so that's wrong, right? Yep, but you got to talk to Emmy a lot, so maybe Emmy knows how to do it.
I put 3/5.
That's wrong too. So far we're on a roll. What'd you get? Perfect. 3 over, let's just call it x, equals 2 over 5. So if you're in the back and you're talking, you probably want to write that down because that's how you set this up. Okay? My other side lengths that are the non-parallel side lengths are proportional, right? 3 over x has to equal 2 over 5, and I'll make that happen by cross multiplying here. Who's my cross multiplying expert now? Earl. Earl. What's 2 times x? What's 3 times 5? Earl, what's 15 divided by 2? What? Good. X is 7.5. Okay? I would then, if you wanted to perfect it, you could do this. You don't have to right now, because I'm not that mean yet. Okay? But you could put those in your calculator and make sure you get the same fraction, the same ratio. Okay? Am I clear on that? Told you. Told you you're going to be cross multiplying. Okay? Look how this one works. Okay? What's my question here? What am I trying to find? Remember how I said it was circular? They would chase each other? Okay? Here's an example of that. Now I'm given all the side lengths, right? I'm given all of these side lengths, but I have to prove that the proportion is true. How do I do that? I take, well, if I'm trying to figure out if DE is parallel to BC, we don't know. Could be, could not be. I would do that by taking 8 over 12, we do it right here, coming up with its simplified ratio, and then taking 10 over 15, coming up with its simplified ratio. In this case, they're both 2/3. Okay? Right? And that simplifies. And when that ratio is the same, notice how I'm going to say this, okay? When the ratio is the same, it means that the sides are proportional. When the sides are proportional, it means that the lines are parallel. See all the steps I got to take? First, I got to verify that the sides are proportional. Okay? I verify that they're proportional by making sure they have the same ratio. Only after I do that can I determine if they're proportional. And if they're proportional, then they're parallel. Can't miss the steps. Can't say, oh yeah, they're ratio the same, and so yep, yes. Okay. Also notice this. What if I change this 1 to 13? It's not going to take a genius. But I'll call on you, Mr. Patrick, anyway. Is 8 over 13 going to be the same as 8 over 12? No. Very good. See? So 2/3 would no longer be that particular ratio, right? Would that mean that the lines are no longer proportional? The sides are no longer proportional? Yes. Would that mean that the lines are no longer parallel? Yes. Okay? Yes, it would. Right? Got to be exact and precise. Okay? My favorite problem today. Go ahead and write this one down. Let's solve it out. Ian. Mr. Confusion. You just say that A to C is 36. The whole distance from A to C is 36. Alright guys, you gotta like read the directions and stuff on these problems, okay? A to C is 36. And AC is 36. How far is A to D? 16. Very good. 36 minus 20 is 16. Does that bother you? Don't let it bother you. It's just subtraction. Yes. Do it now in a practice problem. Don't do it on a test, okay? And B to C is 27. We've gone 15 centimeters. How many do we have to go? 12. Okay. Okay. Now we get to the real stuff. Okay. Let's start this problem for Rizzle. Verify that DE is parallel to AB. That's what I'm trying to do. Before we even begin, let's make sure I'm going to stop and check, make sure everybody knows what we're trying to do here. And how would I have to verify that those are parallel? What has to be true? Sorry, you just said it. Say it again. The sides have to be proportional. How do I know if those sides are proportional? They have the same what? Ratio, right? Okay, so that's how you solve the problem. And guess what? Guess how we're going to do that? Well, actually, in this case, we don't have to cross multiply, okay? All right, check it out, y'all. I'm going to do it like this. 15 over 12. See how I did that? 15 over 12 would need to be the same ratio as 20 over 16. Okay, y'all tell me what that is. Yes. That's okay. That's okay. It'll be a different ratio. It'll be a different answer, but it will be the same. The ratio will be the same. Now, both of these become 5 over 4. Nope, don't have to have it right here. If those are the same, it means that the sides are proportional. If the sides are proportional, it means that my lines are parallel. Right? Got me? So I've got to check off the boxes. Yes, they're proportional, yes, the ratio is the same, which means yes, they're proportional, which means that yes, my two lines are parallel. If you're given, the simple answer is this, okay? It says verify that these are parallel. That means that you're probably not going to have to cross multiply, okay? That makes sense? If it says find A to D, or if you're given that they're parallel, you're probably going to be cross multiply, okay? We just got to see enough of the problem. Okay, let's write this part down. Two transversal proportionality. Theorem. Okay, go ahead and write down all the stuff that I've got circled. Draw your diagram. Explain it. Okay. If 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. Okay? If 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. Let's make sure we understand that. I got 3 parallel lines right there. 2 transversals. Right here and right there. Okay? That means that A over C, the distance from A to C over the distance from C to E is proportional to the distance from B to D over the distance from D to F. what that says. How might I ask you something like this? Well, since we math teachers suck at life, I guess, we always think, oh, they need a real world problem. Okay, let's do a real world problem. Let's do something about trees. Okay? Because y'all love those. Suppose that I'm sorry, that was not me. Suppose that an artist decided to make a larger sketch of the trees. Oh, that's cool. In the figure, AB is 4.5 inches, B to C is 2.6 inches, C to D is 4.1 inches, K to L is 4.9 inches. Find L to M and N to the nearest tenth of an inch. Okay. So now the question remains this. What? How much are the lines? A to K, B to L, what is it? C to M, B to N, right? Correct? Okay. Now check this out. Remember, you're going to be tempted to say, okay, this over this, this over this, this over this. That's wrong. Go the other way with it. A to L over L to M is proportional to A to B over B to C. Okay? So K to L is 4.9 over L to M, which is what we're looking for. That's proportional to 4.5 over 2.6. Okay? If you ever get confused, just start drawing fractions like that. The distance from K to L is 4.9, from L to M is what we're looking for. 4.5 up top, 2.6. That's how your fractions would have to go. If I multiply this out, I get 4.5 times x. I get 4.9 times 2.6. Yes, ma'am? Hold on a second. What is it? 12.74 right here. 12.74 equals 4.5x. Noel, you're now my expert. What's 12.74 divided by 4.5? $2.83. What you gotta do? Okay. So let me get through this one and then we're done. An angle bisector. Here's what you need to write down. Same thing, we'll keep it real. Okay. Anytime I have an angle bisector, the triangle angle bisector theorem. Angle bisector. What's an angle bisector do? Cuts it in what? In half. It takes an angle and it cuts it in half into two congruent angles. And that's handy information because here's why. It also divides the opposite side into two segments. Their lengths are proportional to the lengths of the other two sides. This is the hardest, most confusing one that we've done all day. On the example, it says BD over BC is proportional to AB over AC. Every year I have students that look at that and say, no, that's true. And I'm like, it's a true story. Okay? It's true. I promise. No, Mr. Hall, you're making it up. No, really not, guys. Really not. That's the power of an angle bisector. Okay? Right? I know. It gets so unbelievably powerful, it can put you to sleep. So, let's see this in action. Okay? Last example, and I'm done. I promise. Q to S is my angle bisector. Q to S is my angle bisector. Okay? Which not only cuts this angle Q in half, but it also splits up that opposite side over there, right? Correct? This opposite side over here is going to be proportional. X minus 2 over x plus 5 is proportional to 32 over 40. Please think of it like this. The stuff in blue over here, let me do it like that. The stuff in blue is going to be in the top part of your fraction. And the stuff in red is going to be in the bottom. Okay? What am I going to do right here when I multiply? Cross multiply. Distribute. What am I going to do right here? Distribute. Okay? That's the gist of it. Told y'all be doing this whole cross multiply thing, right? Had to get you straight on that. Any questions? Cool. All right, guys.